Okay, awesome. So yesterday, what we really did, besides kind of just reviewing what was going on here, right, what we had in ToyTail so far, was just actually getting the likes to persist to the database, right? So now when I refresh this, Buzz should have 14 likes, okay? That was simply done by maintaining our optimistic rendering code, which we already have, and also contributing this fetch request here, okay? Any questions about this before we move on? Okay, today we are going to delete a toy, right? So that's going to require us to contribute some information that we have not had before. I'm going to make another button here. We'll obviously fill this in later. And this is going to just be a delete button. And instead of the heart with the slash, or with the heart, it's going to be a heart with a slash. Okay, so pretty simple, just added that HTML there. So who wants to kind of talk out loud what they think needs to happen at this point? I want to be able to click this button to delete this toy. What do I need to do?
Need an event listener?
Sure, I need an event listener. And where do I want to write that event listener? Kind of a tricky question because we can write the majority of the event listener in this component, right? What we might want to do, for example, let's go look at our app.js and let's look at our add like button. Okay. A lot of this could have been done in the toy card component, right? We could have said something like handle like, which would need to be an arrow function because we're passing it as a callback to the button, right? It's an event listener. And I could have put this all here. And then down here, I can finally call the this.props.add like. And maybe at this point, all I want to do is pass in just the toy ID, for example. This is actually a bit cleaner, right? Put the toy ID up here. Obviously, we should parse the integer here so that I can get rid of it in the other places. And obviously, we get E in here. And oh shoot, that doesn't work because let's see. I guess I can just say this.props.likes. That also works. And then over here, when the toy comes in, it doesn't need to be parsed anymore because it already parsed it. So there's some cleaning up our code, not repeating ourselves so much. And also better organization, right? This function now is just responsible for finding the toy. And we actually don't even need to find it here. All it does is change the state. Oh, okay, clearly I lost something. This is supposed to be app.js 21. Oh, okay. Let me go ahead and fix this. What is long? Okay.
Where does handle like actually come in here?
Right here. Handle like.
Yeah.
Oh, that's why I have to put it here. There we go. Handle like. There we go. So now this still not working. But give me a second. And it shouldn't be the step props to handle like. It's just this type handle like. There we go. Okay. So OSHA, so I asked Mark, or I asked the question, what should we do? And Mark responded, let's write an event listener. And then I posed the question, where, right? And then I kind of said, okay, well, it's a little bit more complicated than that because we've written our original event listener inside of the app.js. But what we really need to focus on, right, is that we only need to write event listeners in app.js that grab information and change state, right? Everything else can happen in the toy card if we want it to. It could have all happened in app, but I want to just kind of show that the only reason we write callback functions to change state to pass to child components is just to change state, right? So we can actually just kind of really cut out the rest of that stuff, right? And just write that. And I think I've even done this with some of you all in other examples, right? Let's put all of the fetching logic in here and then only use that one callback function that we've written at the app level, right? To simply change the state at the level of app, right? So I just took all of that out and I put it in the toy card. So this might be a better way of doing it, right? So to answer Mark's question, or to kind of answer the question that I posed to Mark, you might need to write 2 event listeners depending on how we're doing this, right? In the one hand, I had 1 event listener that did everything in here, but to kind of clean up my code a little bit, I wrote 2. I wrote 1 that does the heavy lifting inside of the toy card itself, which makes sense. This toy card should be responsible for submitting the likes. And then I have that other callback function whose sole purpose is to go in and change the value of the likes in state on that level of the application. Okay. So we've seen that both ways work. Promise failed to fetch. I guess I was maybe just clicking too fast. I don't know why it's working now. Okay, so with this example done, Mark, I'll pose the question to you again. Now that we're inside of the toy card, we want to write a callback function to handle a delete. But which of the 2 do we want to write first? And where do we want to write it? Keep in mind also, right, that this is still doing optimistic rendering, right? Because this method is going to run, or this function is going to run, well, I guess it's technically a method. This is going to run before this, right? Because JavaScript is going to read this, put this fetch on the call stack, right? And render this and run this method first. So that's just another thing to kind of keep in mind. Great. If we wanted to make it pessimistic rendering, then all we would need to do is put it inside of a dot then. And now this guarantees that this would happen after. And we could put some error handling in here, right? To make sure that the add like would only go if the response from the API was correct, right? And at this point, maybe we, this is something that we can start thinking about a little bit more, maybe in our one-on-ones. If you're not comfortable doing that yet, then that's fine. But if this makes sense to you, the difference between optimistic and pessimistic rendering, maybe push yourself a little bit and try to think, okay, well, I'll do pessimistic rendering, but I'll do some error handling as well. Or maybe a combination of both. Maybe you can do optimistic rendering, or I don't know. I feel like I'm getting a little bit off topic. Anyways, remember the difference between optimistic and pessimistic rendering and be mindful about it. Okay, Mark, what do you want to do?
Okay, so it's I don't really know the answer, but maybe maybe in the app, because the app is well, we need to change the state of the
Right.
toys.
Okay. So what do you tell me what to do? You say you don't know the answer exactly, but that's right. We need to write a function that's going to remove that toy from the state object. How do you want to write it?
So we are going to we're going to delete toy, right?
Sure, we can write a method called delete toy.
That's what we're doing, right? Or are we deleting the likes?
We're deleting a toy
Okay.
and toy entirely. Okay. Does this need to be a regular? Can this be a regular function, or does it need to be an arrow function?
I think it needs to be an arrow function.
Right. Can you explain to me why?
So that we bind the this
What do we bind
to that instance
this instance of?
of that toy?
Not the toy. If I write the keyword this inside of this delete toy function, what should this point to?
Can
Can someone help them out?
Should point to the state.
What should this represent inside of this method, inside of this function? Burbage, OSHA, Steven, do you guys know what should this keyword point to inside of this method, inside of this function?
A long shot if it doesn't mean toy. Is it the button?
Look over here, right? We're using the this keyword and arrow functions in these two cases as well, right? Yes, Steven's right. We want to be able, this should point to this instance of an app component, right? Because this, that set state is a method that we get from extending React component, okay? It's a method that we don't see here that gets written, okay? And it's a method that's going to assume that this also has access to a state value, right? So when I pass any of these methods as callback functions and I want to change the state, right, this keyword is bound to this instance of an app component so that we can change the state in this instance of an app component. Got it? We want, even though we're going to pass this function to a toy card, on a button on a toy card, that's exactly why we want to bind this keyword to this instance of an app component, right? Hey, although I am taking you and I'm passing you all the way down to a toy card and I'm going to put you on a button, when someone clicks you, the state that I want to change is the state inside of this instance of an app component, right? That's why we have to bind this function, this method, to the instance of the app, because this function, this method's purpose is to change the state of this app component. So if we don't bind this keyword to this method, it will not be able to go back and change the state of this app component. Does that make sense? The concept hasn't changed since we started learning about this back in vanilla JavaScript, right? The purpose was always to bind this keyword to an instance of whatever class we were making. In this case, we're making an instance of the app component. Remember that I can make several instances of app component. And if you look over here, look how many applications I rendered. I've got 3 versions of my application, right? All of them are going to have different states, right? Look at me liking Buzz Lightyear over here, right? But down here, this Buzz Lightyear is still at 14. If I refresh the page, obviously they're all going to make a new fetch request again, and likes will be all updated, right? But because we're using optimistic rendering, I am going in and changing the state. Well, that doesn't even matter, right? Look how for this instance of an app component, Buzz Lightyear has 30 likes. But for this instance of an app component, Buzz Lightyear only has 14, 15, 16, 17, 18, 19. And for this instance of an app component, Buzz Lightyear only has 14, right? These are 3 different instances of our app component. I've made 3 different mini app, 3 different versions of my app. All of them have their own state, right? All 3 of them have their own state attribute. And because we're clicking on toy cards in each of the individual components, they're going to change just their respective state because we bound the this keyword to their instances of app that they're rendered in. Okay? Is that making sense to everybody? All right, so now that I've defined the function, does someone else want to jump in and think about what are we going to write in this function?
Well, first we need to make sure that we pass in the specific toy that we're deleting, right?
Okay, the whole toy or what in particular?
The instance of the, what's that?
Do we need the whole toy? What's one bare minimum thing that we need that we could use to recognize an instance of a toy and delete it?
The ID.
Okay, so we'll take in the toy ID as an argument. And what else?
So now that we have the toy ID, we can find that toy ID and then delete it. I have no idea how to delete it other than doing it through a fetch. Well, I guess you could do like a, but I guess the first step would be to find it, right?
Right. So Ryan, talk with me through, not necessarily how you would code it, but what logistically or like what are you thinking about doing on a what's the word, methodological methodology methodical.
Yes, methodical. I always have trouble saying that word too. Okay. What's my right.
How would you break this down?
First, I would find the toy that I want to delete within the and then I would. The next thing I would do would be to delete it. Well, the 2 things I would do thereafter would be to delete it from the database.
Okay, but we're doing optimistic rendering here, right? So we're doing this whether or not we're doing this whether or not it gets committed to the database. We're doing them 2 separately. We're deleting it from the front end, and then we'll delete it from the back end later. And
I would do the front end first, and then I would delete it from the back end.
We're actually going to do them in 2 completely different methods, right? I broke out the API logic for adding a like over here, and even over here in the form, right? I have the form fetch here. The app just has the methods that are responsible for changing state. They have nothing to do. You're right. There are multiple ways of doing this. We could kind of try to do it all in one.
Well, the state is what holds the toy itself. So I would, after I find the toy, I would change the state to not have the toy in it anymore.
Okay, change the states to not have the toy in it anymore. Okay.
Yep.
So here are the 2 kind of steps. Someone else want to jump in and think about how they would do this? Find the toy that you want to delete, change the state to not have the toy anymore. We have 2 examples of how we've done this, how we've changed state already. Does anyone want to try to pull from one of these? Obviously, none of these hold the exact answer, but we can maybe get some inspiration from them.
So we could set the state, find like use a filter.
Sure. Okay. So talk me through exactly what I should type, Mark.
Okay, so this dot set state,
Okay.
and then previous state.
So this means that we're not passing in set state an object, we're passing it in a function that's going to return an object, right? There are two options, right? At the end of the day, set state is always like, set state can take in two arguments, two potential first arguments, right? The first argument can either be an object or it can be a function that we don't call. Remember I said several times that React often has us write methods that we don't call ourselves, but React will call for us, right? So we can either pass set state an object, or we can pass set state a function. If we pass set state a function, it's going to automatically pass in as an argument the previous state object for us. And we want to use the previous state object when we need to make a new state that's based partially off of the previous state, especially when we're going to be changing something about the same key value pair, right? In this case, toys, right? And that function should ultimately return the new state object.
Yeah, so I think that's what we want to do. We want to take the previous state and return everything from the previous state except for the toy with that toy ID that we passed in.
Okay, so how would we rate that? So here I'm preparing to return an object in OSHA. This is yesterday, remember? When we saw that we were using parentheses here, it's because if I had used brackets, the arrow function would assume that I wanted to break this out into several lines, right? But I'm trying to continue to write this on one line. And in order to do that, I want to return, in one line, I want to return an object, so I have to wrap it in parentheses.
Got it.
Okay, so what do I want to do now?
So previous state dot filter.
Okay, just like this.
I think so.
Yeah, you have the right idea, but you're missing something. We want to return an object, and you haven't given me a key. What's the key supposed to be? What is the key and state that we're trying to change?
Toys.
Right? We want to return state, hey, here's state now. It's still got a key of toys, but the array is going to be different. That's what we're saying, right? Okay, but you're right. We do need a filter. And how are we going to write our filter, Mark?
So we are going to find the
what is filter taken as an argument?
So it takes in the condition.
Not quite. Before we go any further with this, maybe I did something with, I think it was with Ryan yesterday that might be helpful for everybody here. So I was talking earlier about how set state takes in either an object or a function, right? It can either take in an object like this, you know, or it can take in a function. What I did with Ryan is I actually broke the function out into some steps, right? What if I said function add like to toy, right? And I knew that add like to toy was going to receive the previous state object, and that inside of it, I was going to return an object. And in here, maybe I can even break this out into its own method. Add like to toy function. This should actually be add like to toy. And this should be make new state. So the toy object is going to get passed into each of these, right? And this is going to be the callback function. to add like to toy. Oops. Right, we just kind of have, you know, two callback functions going on. Right? Set state gets passed in a callback function. The callback function is going to be not called by us. Set state and React, behind the scenes, React is going to call it, and it's going to pass in the previous state. We're going to use the previous state to construct the new object, return, as always, with a key of toys, and the value is going to be exactly similar to what we're trying to achieve right now with this delete toy method, right? Except in this case, we want to iterate over all the toys and return all the toys, except if it's the toy object, we want to increase the toy object flex by 1, right? And so I broke this out also into its own callback function, right? Take every toy object. If the ID matches the toy ID that we have up here, right? That has access to this via scope. Then return a new object with incremented likes. Otherwise, just return the same old toy object. That wasn't the toy object that we wanted to change, right? Because I think in that case, it was pretty long. I had basically two nested callback functions, and that's kind of tricky to see. So maybe hopefully breaking it out like this is a little bit more helpful, right? This is one callback function, and this is another callback function. But I'm doing, in this case, I'm doing it all on one line, and here I've broken it out into two separate functions. Okay, so keep this in mind. If you're having trouble with set state and writing all this logic out in one line, remember that it's okay to break it out. So if we're continuing here, and maybe I'll give somebody else a shot. Does someone else want to jump in and try to finish this method, this function?
Well, one question I would have is, doesn't toys need to be before filter and after prev state dot?
Oh yeah, prev state dot toys dot filter, yeah. Thank you.
I would use a find instead of filter because we're just trying to find one specific toy. But I think filter would do the same thing, no?
I think you're thinking we want to find the toy that we want to delete, but what we really are doing is, what we really want to do, if I could really, you have two separate ideas here. First, find the toy and then change the state. If I were to bring these two together and say one thing, I would say return the toys array without the toy.
Without, oh, nice, I like it. So that's why filter is better. I know how to find, but I don't know how to do the filter without.
It works just like select in Ruby, right?
But you're trying to find,
So
you're trying to filter out something, right?
Think about select in Ruby, right? Someone explain to me how select in Ruby works on an array.
You're creating a condition and you're finding all the items that match that condition to true.
Right, so how can we apply that same thing? How can we apply that same logic to filter? It literally works the same way, right?
So you would use a, oh, okay. I think what I would do is I would do, so you can put anything in there. Oh, the screen just stopped sharing.
Sorry, I don't know what happened.
All good. So I would do a toy after the filter, the parentheses, I would put in like toy and then arrow. And then I would do toy does not equal to, does not equal to the toy ID. And I would also put in dot at the toy object, I would put dot ID.
Exactly right. Filter through all the toys and return a new array of all the toys that do not have the ID of the toy that we're deleting. Okay. Any questions about this? Does this look okay to anybody? Does anybody want to change this or have questions about it? This is correct. So if we were to break this out again into its own kind of logic, I would write a function called remove toy that takes in a toy object. And then I have a function make new state without toy. That takes in the previous state as an argument. Okay, oops. Should actually just be this. This should actually be this as well. Okay, so our like should work. Now that I've written my function out, what do we need to do? How do I get this callback function onto this button?
You'd use it as an on-click event and call back that delete toy function on the button.
Yeah, but how do I get it down here? I can't just go in here and say delete toy.
You gotta pass in the function as a prop.
Okay, where do I?
So in app, this is a toy card, right, that it's on. So in the app, you gotta go down to the toy container, and then you gotta pass in that delete toy as a prop. Yeah, this delete toy, and then over on the toy container, this prop. I don't know what just happened.
Nothing. Don't worry about it. It's fine.
Okay. Yeah, and then you gotta toy container. You have to make sure that has access to that.
So you'd set up another property in there of this dot props dot.
Whatever you called it in the app. Yeah.
Okay, and then now it should be in here, right? The step prop set delete toy. And then we have to do, right? The problem here is that it's not receiving in any arguments. So here is maybe where we should say our handle delete. Copy this from here and say this dot props dot delete toy and pass it into page. Hopefully this will work now. Here we go.
The toy card is receiving the delete toy method from the toy container.
Exactly.
Where did you? Oh, okay, that's where I got lost because it's going from app to toy container to toy card, right?
Exactly. Uh-huh.
So does every child, like every child has to register and pass on the parent's function in order for the grandchild to use it, right?
right? Any component that any great grandchild component that needs a component in the app or in the highest level needs to be passed down through every level. Okay.
Yeah.
This is something that Redux is going to fix next week. The purpose of Redux is to have a global state that any component can connect itself to without having to pass down prop after prop after prop. But Redux comes with its own headache. It's just stuff. So.
Before we do the fetch on this one, can we go back to the app and talk about previous state again? I know you just did, but
Yeah.
So I understand what's happening in but I just don't necessarily know how to read the previous state and why, you know, that's an argument and how it's being used.
Right. So set state is a function that comes from our React component, right? It's an instance method that we inherit. That's why we don't see it here, right? It's from our inherited class, right? So as I kind of touched on yesterday, we can imagine that set state is defined in another class, right?
Yeah.
And set state, and again, I'm pseudocoding here. I don't know exactly the real syntax, but we basically set state basically gets passed in an argument, and it asks if the argument is an object, right? For example, again, pseudocoding here. Okay, so then, you know, combine this object with the current version of state. And then otherwise we say, oh, it's a function, so let's invoke that function and let's pass in a previous state argument. So the question maybe for you is, where is previous state coming from?
Mm-hmm.
It's a good question. There are such things as the set state function probably has some logic in here that has connected it to some inner workings of React which might in this case point to something called context, which we'll learn about a little bit more when we talk about Redux. But I don't know how set state has a guaranteed version of the most up-to-date version of state, but it does. And I imagine that it is through something called context. Or again, there are certain methods that React writes for you that have access to things that we don't have access to, because in React, there's this kind of logic of what they call like the immutable state tree, or that things that have to do with state should never be 100% accessible to us. That's why we have to do this kind of set state ceremony instead of going and changing the state directly, right? Like what's stopping us from saying this dot state equals and then just changing the version of state, right? There's a reason we don't do that, because React says, no. We need to add a layer between the coder changing state and state itself, so that there is a process, so that nothing gets fumbled along the way. And I think what React does is it takes away a little bit of your power and says, okay, you have to follow just this process, because again, there's some inner workings inside that allow us to make sure that state is always changed in the correct order at the correct time.
So
Right?
we can't call on state in our functions because of React's guidelines. So
Yes.
they assign it as previous state. And then, so we're using previous state, even though kind of in some coding world, it's actually state. Is that right?
Exactly.
And then set state is like the future of what we're making it.
Exactly. And remember that React can choose to batch set states, which is why you need to use previous state, because the argument coming in here, again, there's a lot, I'm extremely oversimplifying set state. It's a very powerful function, very powerful method, right? React also has logic to say, okay, well, we might have to batch. If you have a huge application and there are like dozens of set states all being blasted off at the same time, React might batch those for efficiency purposes, right? And because of that, there is no guarantee that if you were to say this dot state is the most up-to-date version of state, right? Because you might be calling on a, you might be calling this, you might say, hey, imagine that you have an application that has like a countdown in milliseconds, right? Like an insanely fast countdown that's changing set state extremely rapidly, right? And every time that you are counting down in milliseconds, you're changing state, but you're expecting that this dot state is the most up-to-date version of state, right? Well, if React batches all of those, then if every time they fire, this dot state would actually be the original state, which if we're counting down from like 1,000 milliseconds, all of those would register 1,000 as the version of state, right? Because React actually hasn't actually updated it. So we use previous state as a way, or the second potential argument of a function is previous state, because React will recognize, hey, if someone passed in a function, that means that they're expecting the most up-to-date version of state to update, to be updated. So even if they get batched, even if 10 get batched or 1,000 get batched, right, they will fire off in a particular order and have this previous state passed in so that the user assuredly has the most up-to-date version of state if React decides to batch the set state methods. Okay.
So is previous state then always the most up-to-date version of state?
Exactly. Which is why I say if you ever need to update state using a bit of information from the most up-to-date version of state or from state itself, you need to always use the function that has previous state passed in as an argument. Always. Okay. Always, 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 always. So if you're ever writing something and you see yourself saying like, again, we're only firing off one set state at a time. So if you were to commit this error, you would not notice a difference. Let's watch. Let's see. This one's kind of tricky to do, I guess, because we have to add, and I don't really feel like adding, but I won't do it. I'll just show you. So if I were to say toys, and I want to say, okay, bring in, and remember, this only happens if we are updating state on a key that has information in it, right? Because we all know that when the objects get merged, if the key already exists in the object itself, it's going to get overwritten, right? So I'm trying to change the value of toys in my state. However, I want to make sure that all of the toys that are already in there get brought over. I don't want them to be erased, right? So what would seem logical to do is to say, hey, bring over this .state.toys and then add the new toy object, right? This would be the logical way to do it if we didn't have to use previous state. And again, I guess I'll just go ahead and do it. Let's get rid of this nasty method. Maybe I'll just comment it out so you can see it. If I take Woody again, Woody2, and I add him in here, of course it's going to work because I'm not firing off fetch requests or set states fast enough for React to batch. And it's also not really causing me any problems, right? It's predictable enough that this would work, but it's an anti-pattern. React doesn't want you to do this. It works, yes, but it could cause problems in the future. If your application got immensely huge and you had several set states firing at the same time and React decided to batch them, right? Or in this case, if you added several objects, I don't know, let's see. I don't know, I really don't even know how many times I clicked it. There could be a world in which we clicked it 15 times, but only 10 registered because 5 of those set states got patched, right? That's kind of the point here. So whenever you see yourself saying, hey, we're going to change the key in the state object, and we need to bring in some of the pre-existing values in there, to contribute to another one, right? Or in any of these cases, right? We still need, you know, in all of them so far, we need to preserve some form of the previous state. That means that the argument now needs to be, it's not enough for it to be just the object, it needs to be the function that passes that state in so that it's more controlled, or previous state in so that it's more controlled. Okay?
Yeah, totally. That makes sense. Thank you.
Any other questions?
Thanks, Chris. Could you please just put under the delete toy, could you put it all in one line again, just so we can have it for comparison while keeping this?
Sure. I would say this, that's it. The it would be this.
So in this case, Crud state, like PREV state, just to make sure I understand, that's actually has to be explicitly called for previous state. And
No, call it whatever you want.
oh, really? Oh, shoot. But React just knows whenever you're setting state that the first argument is going to be the previous state.
Yes.
Okay. And then in this case, it's taking the previous state and then it's filtering it out. Okay. What's the second argument in this statement?
So set state always can only take two arguments. The first argument can either be an object or a function that returns an object, right? So here we're passing it a function that's returning an object, right? The second argument is always a callback function that gets run after set state has completed, which is why I like to put console log this set state here.
Oh, but you don't need the second argument.
No, it's optional.
Okay, so as long as the first argument is an object, you're good.
Or a function that returns an object.
Or a function, right. Okay. Thank you.
Okay, but we haven't actually committed the deletes to the database, so we have to make our fetch request now, right? So in our toy card, we can basically kind of just copy this, right? You guys have done lots of fetch requests, so this case it's going to be delete, and we don't even need a body. Right? Let's get rid of all of these woodies, and hopefully when we refresh, they're not there anymore. Okay. That's it for delete.
That was crazy easy.
Yep. Anything else? Okay, last thing that I want to show you all is what we're going to talk about tomorrow, which is routing. So, you know, imagine that I either want to show all of the toys or I want to show the form. I don't want to have them both at the same time. Really, that's not something that we, you know, generally see in websites, right? So I either want to see the form or I want to see the toys. And let me get rid of our multiple instances of app here so that I think I made my point. We don't need to see these anymore. Oops. Okay. So I either want to see the form or I want to see the toys container. I don't want to see both. Okay. Can anyone think of a way that we could get that to work? how could we say, hey, if someone wants to see the forms, let's just show them the forms. If not, or if they just want to see the toys, let them see the toys. Very easy, okay? Just go into your state and add a key of page and set the default to, maybe we'll just set the default to toys, okay? And then down here, I would write some logic, like a ternary operator maybe. Obviously this is easier if I only have two options, right? There can only be one component or the other. I can say something like, this dot state dot page is equal to toys, question mark. Okay, well, render the toys container. Otherwise, render the form. Okay, now we don't see the form, just see the toys. Maybe up here on the button, maybe we can put a button and we could say something like, this dot state dot page equals toys, question mark. Then the text will say view form. Otherwise, it'll say view toys. Okay. And then I can write a callback function that just says change page. It's going to be a callback, so it needs to be an arrow. And I can write this dot set state. I'm going to need the previous version of state, right? And then because I'm just changing one key value pair, I only need to include page. Page equals, and then same thing again. Previous state dot page equals toys? Question mark? The answer is no. Put it to form. If the answer is yes, change it to form. Otherwise, switch it back to toys. And then, oh yeah, got caught in that problem again. And then I just add the event listener on here. On click, this dot change page. I'm going to view the form. I'm going to view the toys. I'm going to view the form. I'm going to view the toys. Got it?
I don't get where the form and the toys are even coming from. This page.
Right here. It's just a ternary operator.
Well, right. I understand. Yeah, I get that. I'm saying like toys you defined in state just a moment ago, but I don't know where you defined form. Like how is it referencing? I don't get how it's
so Ryan, on the line where like down inside the render, I think it's like line 71 or something. No, 72. After the question mark, do you see it starts at the div of calling on either the toys container or the form container? In between the
page, toys. Oh, I get it. But where's the form though?
After the colon.
Oh, so the form doesn't even need to be referenced? Toys.
So it's an either or with the question mark, the ternary?
Right, okay. So it's not like form in this case.
It's calling on the container.
Right. Okay. Thank you.
It's not.
Sorry about that.
We're not hiding it. No, thanks, Sosha. I appreciate it. We're not hiding the toys container or the form. We're literally just not rendering them. If we want to go look at HTML, the form isn't even here. Right? There is no form. There's just the button to view the form. The toy container goes away. This is components unmounting and then mounting again. Right? Okay?
Yep.
So tomorrow what we're going to learn is how can I handle this conditional rendering? That's what this is called, conditional rendering. How can I handle this conditional rendering but based on URLs that the user types in? How can I have form take the user to just the forms? And how can I click on a button that'll change the URL to toys that would change it to toys and vice versa? How do we use URLs in our JavaScript applications to handle conditional rendering in our applications? Okay. I'll post the code to this in a little bit. And if somebody wants to challenge themselves, I know that I've given everybody kind of homework already this week outside of the lessons themselves. But I want you to think about this logic here of the conditional rendering and maybe go in and add an edit for the name and the image of a toy. But how could you get it so that if I had an edit button down here, if I clicked it, right, it would, a form would appear. And then if I maybe clicked cancel edit, it would return back or save, right? Can you use conditional rendering on a toy card to either show the toy card itself or show the form? And I think that some of you should have, there's a kind of a lesson on this, like the front and the back of a component. I don't really like the way that that lesson works. So if you want to challenge yourself further, you know, put an edit button here that would just be able to change the name and the URL of the photo, and write it so that you can use the same toy card, but you'll use conditional rendering to determine is the toy card showing the front or the, you know, the saved version, or is it rendering a form? Okay. And then how might you even take a toy card and split that logic into two further components? A toy card can have a front, which is the display, and a back component, which is the edit, the form itself. Right? Okay, but that's it for today. Thanks everybody for coming.